All right then. So today we are looking at sine and cosine graphs from the perspective of the unit circle. So we're trying to make a bridge from seeing things in the unit circle to start sort of visualizing it as a graph a little bit. One of the key things we want to look at is how the sine and cosine functions are changing as the theta changes within the unit circle. So let's start off with this exercise. Take a couple of minutes to fill in the exact values for the sine and cosine values. Sorry, for the sine values here in this table. So take a couple of minutes to fill this in. We're not doing the cosine on this one, we're just going to be doing sine. Have I got filling this in? All right, so our values, our exact values are going to be, ooh, that pen's too big. This one's going to be a half. This one is going to be root 2 over 2. This is going to be root 3 over 2. And then we come up to 1. Then we start to go down again. And we get these values. We return back to 0. What about this next one? What's that one going to be? Yeah, so it's going to be minus a half, minus root 2 over 2, minus root 3 over 2, minus 1, minus root 3 over 2, minus root 2 over 2, minus a half, back to 0. So if we look at these values here, we can see the decimals. If we have a go at sketching that, how is that looking? How is that looking if we sketch this function a little bit? Well, I'm not going to draw it in the unit circle. I'm going to draw it like this, whereby this is our theta values, and this is sine theta in this direction. So what we're going to get, if you notice with your values, they come up to a maximum here, and they go to a minimum there. They come up by a half. In that first gap, the change is a half. Then it's 0.2. Then it's 0.15. Then it's a little bit less than 0.15. So the rate at which it's changing is getting less and less. So this is going to give us a shape that looks like this. Look at the rate of change here. This is 0.5. What is this next one? 0.2, should we call it? This is 1.6. And this is about 1.3. I'm rounding a little bit there to two significant figures.
0.1.
Oh, yes. Thank you. I get you.
So what are you doing?
I'm rounding. So if we look at the rate of change is getting less and less. What is the rate of change here?
Minus 0.2, minus 0.1434.
Well, it's obviously going to be the same value that I wrote there, so 1.13. So I'm calling that sort of 0.87. It's the same but negative. It's the same but negative, but it's going down like this one. And then we're going to go minus 0.2, and then the last one, minus a half. What about the rate of change here? So it's minus 0.5, minus 0.2, minus 0.16, and so on. What about the rates of change here? These are positive, aren't they? And are they getting bigger or smaller?
They're getting bigger.
These are positive and they're getting bigger. So if we're looking at the graph, where is the rates of change positive? The rates of change are positive here, and here. Where are the rates of change negative? Here and here. And you can see that graphically as well. All right. We just did this. Okay, let's have a look at this example question. Have a go at reading the question. Give you 2 minutes to have a go at it for yourself, and then I shall explain it through. All right. So this style of question, it's actually quite easy to do, but it's a little tricky as usual in the wording of the question. So we've got a unit circle drawn here. Hopefully everybody can see where the angle theta is. The angle theta is this rotation here to this point, and the terminal ray of theta crosses at P. Now, where is the angle omega? Where is the angle omega in this?
No.
Go and point to me, shade the area on the screen, where it is. Is it negative, the value?
Yeah.
So for those following the video at home, Yusuf thinks this is the angle omega. What is wrong with this statement? So if this is true, then we've got omega, which is a negative angle. And it's going to be somewhere between. So what you're drawing with that blue line is we're somewhere between minus pi over 2, omega, and minus pi. So you're placing it there in this interval. That's this interval here. Okay, so no, this is not correct. There. Okay, so we're looking at the angle omega here. Where in the diagram is the angle omega? Rudram? Yeah, I think it's best if you point. Where are you? Here. So Rudram says that this is the angle omega. Is he correct? No. What Rudram is saying is he is saying that omega is equal to 3 pi over 2. Is that correct?
No, because it should be less than that. 3 pi over 2.
Okay, Jude. So where is the angle omega? Where is the... In this range. Yes. Yes. So, we know from this statement, where is it? We know from this statement here that omega lies in this region here. Omega lies in this region here. So secondly, it introduces us to this g of z function. All g of z is you put in an angle into the function g, and it gives you the cosine value. You put in an angle into g, and it gives you the cosine value. So let me just write this down. G of theta is roughly how much?
Negative 2 square root 2 over 2. Negative square root 2 over 2.
Sam's correct eventually. He gets there with his thinking. So it's roughly this one. Sam is seeing this one as roughly pi over 4 there in that particular rotation. So this angle here is a reflection of that cosine value. So it's roughly this value. Is the cosine value of omega less than this, more than this, or does it vary?
It's always less.
Why is it always less?
Because it's moving towards you for the x value.
So we have this vector here. This vector here is g of theta. This vector here is g of theta. This vector here is quite possibly g of omega. Which one is the bigger value? The red one or the black one? The red one is the bigger value. Why? Why is it the bigger value? Jude.
On the x-axis, it represents
What can be tricky with this is the black line is longer, but it's moving in the negative direction. So it's a bigger negative value. So the black one is something, it could be something like minus 0.8. Whereas the other one was minus 0.707. Which one of these is bigger? Which one of these is bigger? Oh, sorry. Let me write them the other way around. So omega could be something like this, 0.81. And theta could be something like this, 0.7. Which of these is bigger? Oh, sorry, let me add the minus signs. Which of these two is bigger, these two numbers? The red one, the red is bigger. The red is bigger. So which, finally, is the correct answer? B. B. All right, let's move on. Have a read through this question, give you a couple of minutes to discuss it with your partners. Let me just pause. Obviously, there's a few ways we can think through this problem, but what I would like to do is I'd like to do it from a very visual perspective. I like to do it from a very visual perspective. So first, I'm going to start off with my unit circle. My unit circle looks like this. Come on, unit circle. There we go. Now, firstly, we have theta is in this interval. Which quadrant is that? That's this quadrant here, isn't it? Next, I'm going to draw some axes like this. So if we're starting here if this is theta, and we're talking about the cosine of theta. So this is theta here, and we're going to go from pi up until 3 pi over 2. So in the unit circle, the first angle we get to is pi. That means we're going to be here. What is the cosine value here?
-1.
So the cosine value here is going to be there at -1. So the cosine value, where do we see it? We see it as this line here, like that, don't we? So next up, we are going to rotate round to about here. The cosine value is this line here. Is that more or less than -1?
Less. No more. It's approaching 0, and it's the cosine.
Estimate the value for me as a decimal. One decimal with one decimal place.
Oh, it is more. Wow.
So here is -1. Let's say this is minus 0.8. Let's call this one minus 0.8. So it's going to be about here, isn't it? So now as we make theta bigger, as theta increases, what is the cosine value going to be?
-0.5, maybe?
Yeah, let's call it -0.5. So it's going to be about there. And then as we get to this point here, This is when we get to 3 pi over 2. What is the cosine value here? 0. So we're going to be there. So the shape of our curve looks like this. Is the curve increasing or decreasing? Increasing. Is it concave up or concave down? Sorry, can we have quiet? Let's hear Yusuf's question, Yusuf.
No, I was asking you here earlier. If you look at the angle going like this and be like, oh,
Yeah.
it's going down, decreasing, and it's concave.
That would be the sine value.
Oh, that would be the sine.
Yeah, that's the sine. Because the sine value is easy here because the sine value looks like the circle, but the cosine value doesn't look like the circle.
So I'll think about it like this.
No, in the same way that I did, where you start at pi and then you look at what the cosine value is.
On a graph like that.
Sir, can't you just take this and flip it this way?
Yeah, he's right. Rotate, it's called.
Like this? Doing it together?
All right, let's move on to the next one. Okay, have a go at this one. Discuss with the people next to you. Let's have a look. Where are we? A little bit trickier, this one. Okay, so let's start off by, what are we going to draw to begin with? Unit circle. Let's draw a unit circle. Let's visualize our problem a little bit. Always, when you're stuck on a difficult question, if you can draw a diagram to help you, then great. So, this interval here, what are we talking about in the unit circle? We're talking about the second quadrant. So, omega is lying here. Next up, omega, we're going to be putting it into the cosine function. So, we want a cosine value. We want a cosine of omega is equal to minus root 3 over 2. What would that give us as a solution? All right. We seem to be getting multiple answers here on this one. Let's see how we would think to answer this question. So first up, we need the cosine. Sorry, Mohammed, John. If we go to our exact value table, we get 0, pi over 6, pi over 4, pi over 3, pi over 2. This is our exact value table. And the cosine values start at 1, root 3 over 2, root 2 over 2, a half, and 0. So because we want root 3 over 2, we're looking at this. But that would be in the first quadrant. So we know it's going to be a reflection of this line. So our line is going to be over here. This is our interval. This would give us the angle 5 pi over 6. Now, the only thing we need to do now is to turn it into an inequality. So we want the cosine value to be less than this. That means the cosine value has to be more negative than that. So at 5 pi over 6, that's around about there. So that's this one. We need anything which is even longer in the negative direction. So it's going to be this part here. It's going to be this part here. They will all have lines longer in the negative direction than that. So our answer to the question is 5 pi over 6. Sorry, my Zoom call ended. I'm just going to fix that and then continue speaking.
So I love your background picture.
It's my wife's. It's That,
not an Apple one. That's
yeah, that's Spain. That's the coast in Spain. I like Spain. I might get a house in Spain. Maybe there. That's the white coast.
hello. Ah!
Okay. All right. Sorry about that. A little bit of a pause there. Sorry. Can we have quiet again? All right. I should have paused the video. Sorry about that. So our angle is going to be from 5 pi over 6 up to pi. Now let's think about the intervals at the end. Do we want 5 pi over 6 included or not?
No.
Why not?
Because it's not negative.
It would be equal here. Do we want pi over 6 included or not?
Yes.
Sorry, do we want pi included or not?
Yeah, because it's still going to be negative. And it's going to... Wait a minute.
No.
Yeah.
This boundary says that we don't include pi. This boundary says we don't include 5 pi over 6.
But sir, -1 is less.
No, but the restriction.
There's a restriction on omega not including pi. It would have to have a line here to give us a line there. All right, next question.
Sir, if we write,
Have a go at this question now.
Sir, for that question, if I write negative, if I write 5,
I feel it's fair. All right, so let's start off by drawing our unit circle. Here we go. Unit circle me. Which quadrant are we looking at?
4.
We're looking at the fourth quadrant. So I'm just going to draw, I'll do it like this. I'm just going to draw a few angles. We've got this is our first angle, 3 pi over 2. Here's our second angle. Here's our third angle. Here's our fourth. So I've tried to do 4 equally spaced angles. Then we're going to do the cosine value. The length here is 0. This is the cosine value. This is the cosine value at that one. And this is the cosine value at that one. So our values of cosine as theta increases, it starts off at 0. And then this is quite a big jump here. Then we have less of a jump. And then we have even less of a jump. We're getting a graph that's looking like this here at that point.
Increasing at a decreasing rate.
We would say that it's increasing at a the function is increasing at a decreasing rate.
Sir, can you just look at it like the graph?
Now, wait. The function is increasing. Is the rate of change increasing or decreasing? Look at the Look at the wording of the question. Which of describes the rate of change? So the function is increasing at a decreasing rate. The function.
The rate of change is decreasing at an increasing rate. Oh, no. If you read the question and really visualize the problem,
Are we not? Sorry, little kids. Don't feel bad today.
Wait, no.
So is it called?
guys, can we focus back on the math? Thank you.
It's going up and it's approaching 0. Shut this up.
Okay. So, we want to look at the rate of change. Is the rate of change increasing or decreasing?
Decreasing.
The rate of change is decreasing. Now what about, is that at an increasing or decreasing rate?
At an increasing
It's concave down. It's going up, but it's a positive zero. The rate of change is
because it's coming like.
Yeah, that's what I'm saying.
No, sir.
Well, it's decreasing.
Increasing rate.
It's decreasing rate.
Look at the y value, right?
Look, sir, it's changing less and less, and it's changing even less. That means it's increasing its losses.
Sure, I still think it's B.
I said it's increasing how much less it is. Do you know what I'm saying?
No way it's B. I refuse to believe it.
That's it. I think it's C. Yusuf, I stand by my C. We can think about it.
All right, let's see a show of hands. Who thinks it's C? Who thinks it's D?
So I still think it's B.
What is Jude?
So it's B and I can prove it. So the answer is B.
You're out of the.
She must think she's her.
Wait, no, it's increasing.
Sir, the answer is C.
Absolute idiot. It's D.
It's decreasing at a decreasing rate.
I don't get it. Sir, the answer is B.
Sir, I can prove it. I can prove
Why did you move?
I feel a bit smarter sitting here. Accepting others.
Look at Jude's face.
Wait, sorry.
Good afternoon, elementary school. I'm Dima, your Sharkstrap captain.
So where were we with this one? All right. So the rate of change here at the rate of change here at this point is maybe going to be going up by 1 here at this point. The rate of change is going to be about 0.5 here, about 0.2 here, and 0 here because it's horizontal. So if we look at how the rate of change is changing, the rate of change is changing by, it's gone down each time. The rate of change is getting less and less. So the rate of change is decreasing at an increasing rate. So the rate of change is going to be decreasing because it's going from 1 down to 0. It's going to be decreasing, but we're going up towards positive numbers here. We're going to be up towards positive numbers here on this one.
So can I prove that it's B, please?
So it's decreasing at a increasing rate.
C? Is it C? It's C.
No, it's D.
All right. So we've got decreasing at an increasing rate. Our last question. The function is given here.
So I don't want to see math for like this.
Have a go at solving the inequality.
So is the base 10? Oh, no.
Can we try and solve this quietly, please? I shall pause the video for you for a minute. Okay, so on this one we're going to use our calculator. We're going to graph it. If we graph it, we need to graph it on the interval from 0 to pi, like this. So we change the graphing settings on our calculator, and then we sketch the graph. It's going to look like this. Oops. It's going to look like this. Like that. So using our graphing calculator, we can find the values
So wouldn't it be 4
here,
times?
here, and here.
Oh, no.
Now, this first one is going to be, what did I get? It's going to be pi over 6. This one here is going to be pi over 2. This one here is going to be 5 pi over 6. And obviously we start off. So our solution to this one is that omega is between 0. Oh no, we can't include that one. Omega is between, where are we? Between 0 and pi over 6. Or omega is between pi over 2 and 5 pi over 6. And this is our answer. All right, we're finished there for today.